Hi class, welcome to exercise 5A, solving quadratic equations using the quadratic formula. In this lesson, your examples and pre-learning will be example 20, using the discriminant. And your pre-learning for this question will be questions 1 and 2 in the new book and questions 4 in the old book. And then we'll do example 21, solving quadratic equations. And your pre-learning for this example is questions 3 and 4 in the new book and questions 5 and 6 in the old book. So this is the final lesson on quadratics as pure algebra. Following this, we'll begin to graph them. Today, you get to use a theoretical approach that helps you understand why a quadratic has 0, 1 or 2 solutions. This is an ancient formula, and understanding it depends on you understanding how to complete the square. Alright, we'll see you in the introduction. We've been solving quadratics with 2 methods, but generally speaking, for which values of x does a times x squared plus b times x plus c equal 0? So if I was to divide both sides by a, well, ax squared divided by a is x squared, bx divided by a is b divided by ax, c divided by a is c divided by a, and 0 divided by a is still 0. And because b divided by a divided by 2 equals b divided by 2a, and b on a divided by 2 is equal to b on 2a. So this is where you need to understand completing the square, because if I add b on 2a squared and minus b on 2a squared, we've essentially added nothing. Alright, so this here is just adding 0 to our equation. Now hopefully you can recognize that this part here is completing a square, and focusing on the b on ax, well, it needs b on 2a, right? So that then becomes x plus b on 2a all squared. All right, and let me just note that this part here is completing the square. And of course, we've got this extra minus b on 2a squared and the c on a still equal to 0. Now, if we approach this like the alternative method I was speaking about in our last lesson, we can readjust this to x plus b on 2a squared equals b on 2a squared minus c on a. And obviously I've just subtracted across the b on 2a squared and the c on a. Just a hint of what's to come, c on a times 4a on 4a is really just c on a, right? Because the 4a on 4a is just 1. And then if I expand that out, we get c times 4a or 4ac on 4 times a squared. And keeping that in mind, if I square the brackets on the right, we now get x plus b on 2a squared equals b squared on 4a squared minus 4ac on 4a squared. And looking at what we've got here on the right, you can see that I've done that deliberately to make sure our b squared and our 4ac are on the same base. So the next step from here is to take the square root of both sides, and that will get rid of the square on the left, right? So the square root of on the left is just x plus b on 2a. But on the right, we've got all that stuff there, so we have to take the square root of the whole thing. And also note that I've just written it on the same base because those things were on the same base. And just as another little side note, let's not forget that the square root of b squared minus 4ac on 4a squared is equal to the square root of the numerator divided by the square root of the denominator. And 4a squared is just 2a, right? So now if I subtract b on 2a across, I can fix up the square root on the bottom as well. And look, I've made a little bit of an error along the way here. I should have had a plus and minus for that square root, of course. So all this long algebra leads to the fact that a times x squared plus bx plus c equals 0 when x is equal to minus b plus the square root of b squared minus 4ac on 2a, or x is equal to minus b minus the square root of b squared minus 4ac on 2a. And so the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Take a second to absorb that. This is an ancient and famous formula. You should feel privileged that it has been passed down from generation to generation, and it's now your responsibility to carry this into the future. Inside the quadratic formula, we have a key piece of information called the discriminant, and we denote it with this symbol. And the discriminant is all the stuff in the square root. So that's equal to b squared minus 4ac. And the amazing thing about the discriminant is that it will tell us exactly how many solutions there are for ax squared plus bx plus c equals 0. And this is because if the discriminant is negative, i.e. b squared minus 4ac is less than 0, then we've got this b squared minus 4ac all square rooted. And we're going to have to take the square root of a negative. And you know that this means we've got 0 real solutions. At this stage, it could be very complex for you to imagine what the solutions are, i.e. x is equal to minus b plus or minus some square root of a negative divided by 2a. So yeah, I don't know if you can think of an x like that right now. Anyhow, if the discriminant is equal to 0, in other words, b squared minus 4ac equals 0, then the square root of b squared minus 4ac equals the square root of 0. So then our x is going to equal minus b on 2a plus or minus the square root of the discriminant on 2a, which will end up equaling minus b on 2a plus or minus 0. And of course, plus and minus 0 is the same thing, so this quadratic has one real solution. And it also means that ax squared plus bx plus c is a perfect square. And finally, if the discriminant is positive, which of course means that b squared minus 4ac is greater than 0, then the square root of discriminant will equal some positive number, which we'll just call d. So this means that when x is equal to minus b on 2a plus or minus the square root of the discriminant on 2a, so remembering we've called the square root of the discriminant d, then x is going to equal minus b plus d on 2a, or x will equal minus b minus d on 2a. And therefore our quadratic has two real solutions. So the textbook has this table, which is a great way to explore the values of a, b and c, and what that means for the discriminant and the solutions of the equation. So here you can see we have our three equations, and we'll list what a, b and c is, what the discriminant is, and what the possible solutions will be. So for the first one, we can see a is 2, b is 7, and c is 1. So therefore our discriminant is equal to 7 squared minus 4 times 2 times 1, which is 49 take away 8, which is just equal to 41. So therefore minus b is minus 7, and plus the square root of the discriminant is the square root of 41, and 2 times 2 is 4. And the other solution is all the same except for minusing the discriminant. Okay, for our second equation, we have an a of 9, a b of 6, and a c of 1. Therefore our discriminant is 6 squared minus 4 times 9 times 1. And 36 minus 36 is 0. So remembering minus b is minus 6, and 2 times a is 18. Our first solution is minus 6 on 18, which is just minus 1/3. And because the discriminant is still 0, we're going to end up with the same for our quote-unquote second solution. Then for our last equation, we've got an a of 1, a b of minus 3, and a c of 4. So using some brackets so negatives don't get confusing, we end up with minus 3 squared minus 4 times 1 times 4, which is 9 minus 16, which is minus 7. So our first solution would be 3 plus the square root of minus 7 divided by 2, and the second one is 3 minus the square root of minus 7 divided by 2. All of those numbers we found there were just using the a, b and c from the equation. And while doing the algebra at the start there to show you how we get that equation can seem a little bit complicated, using it is really straightforward, as you can see. Without even getting to the point where we figured out the last two bits there, the solutions, just by looking at the discriminant, we could see that 2x plus 7x plus 1 equals 0 has two solutions, because its discriminant is positive. 9x squared plus 6x plus 1 equals 0 has one solution, because its discriminant equals 0. And the x squared minus 3x plus 4 equals 0 has no solutions, because this discriminant is negative. So maybe I should quickly write that in. Alright, but in the exercise we'll expect exact solutions. So I think this can be a challenging concept for a lot of students, so you really should pause the video and do the building understanding questions in the new book, which translates to questions 1, 2 and 3 in the old book. And so just before you go, I'd like to mention that while the idea of the same sort of equation having a different number of solutions may seem weird now, the number of solutions will make much more sense when we start graphing parabolas. Alright, I'll see you in the next section. Before we find the solutions of a quadratic equation, we can use the properties of the discriminant to tell us how many solutions there will be, and this is a really handy fact. So as we said in the introduction, for ax squared plus bx plus c equals 0, the discriminant, denoted with this triangle, is equal to b squared minus 4ac. And when the discriminant is greater than 0, we get 2 solutions. And when the discriminant is equal to 0, we get 1 solution. And when it's less than 0, we get no solutions. Alright, so let's put this fact to use in example 20, where we're going to determine the number of solutions for the following quadratic equations using the discriminant. Alright, in part A, our quadratic equation is x squared plus 5x minus 3 equals 0. So this means that a is equal to 1, b is equal to 5, and c is minus 3. So therefore our discriminant is going to equal 5 squared minus 4 times 1 times minus 3. And 4 times 3 is 12, and we've got a minus and a minus there. So we end up with 25 plus 12, which is equal to 37. So because the discriminant is greater than 0, there has to be 2 solutions. Okay, part B, we have an equation where it's 2x squared minus 3x plus 4 equals 0. So therefore a is equal to 2, b is equal to minus 3, and c is equal to 4. So our discriminant is going to equal minus 3 squared minus 4 times 2 times 4. And therefore we get 9 minus 32, which is minus 23. And as our discriminant's less than 0, there are no solutions. And in part C, we have a quadratic equation of x squared plus 6x plus 9 equals 0. Now, without going any further, I know this is going to be one solution because x plus 3 squared will equal x squared plus 6x plus 9. But anyhow, let's go on with the exercise here. A is equal to 1, b is equal to 6, and c is equal to 9. So therefore our discriminant is equal to 6 squared minus 4 times 1 times 9, which equals 36 minus 36, which is 0. And as our discriminant's equal to 0, there has to be one solution. So you could write out a square in just straight out algebra notation and see why the discriminant will always be 0. But I'm not going to use any time in this video for that. I can discuss it in class, or as I said, you can try it yourself. But anyhow, we've reached the end of this example. So right now you should pause that video and do questions 1 and 2 in the new book and questions 4 in the old book. And just before you go, I'll say that while the equation is fairly complicated, using the discriminant is not. Alright, I'll see you in that next section. So we can use x equals minus b plus or minus b squared minus 4ac square rooted divided by 2a, otherwise known as the quadratic formula, to find which values of x satisfy a times x squared plus bx plus c equals 0, just by subbing in the values of a, b and c into the quadratic equation, which is pretty amazing when you think about it. So let's try it with example 21, where we want to find the exact solutions of the following quadratics. And of course, exact means leave surds as surds. Alright, part A, we have x squared plus 5x plus 3 equals 0. So therefore, a is equal to 1, b is equal to 5, and c is equal to 3. So plugging those values into the formula, we get x is equal to minus 5 plus or minus the square root of 5 squared minus 4 times 1 times 3 all over 2 times 1. And of course, you don't have to write out 4 times 1 times 3 or whatever in the future, but that's very important that I do it at this stage so you can see we've got the 4 and the 1 represents the A and the 3 represents the C. And I'd be happy if you jump straight to the next step, which is minus 5 plus or minus the square root of 25 minus 12 all over 2. And as 25 minus 12 is 13, we've now got minus 5 plus or minus the square root of 13 over 2. So of course, remembering that plus or minus means there's 2 different options there, our solutions are x equals minus 5 plus the square root of 13 all over 2, or x is equal to minus 5 minus the square root of 13 all over 2. And as you can see, we've got solutions that have nothing to do with integers here at all. The square root of 13 is definitely a surd, definitely a rational number, but we can still check these results. So let's have a check. Okay, so if we have x is equal to minus 5 plus the root of 13 all on 2, then x squared plus 5x plus 3 will become that value of x squared plus 5 times that value of x plus 3. And expanding that squared bracket on the left, we end up with 25 minus 10 times root 13 plus 13, all on 4. So 5 times x will end up giving us minus 25 plus 5 times the square root of 13, all on 2. And of course, we've still got our plus 3 at the end. So 25 plus 13 on 4 is 38 on 4. And looking at the other number over here, we've got minus 25 on 2. We've got a minus 10 root 13 on 4 and a plus 5 root 13 on 2. And of course, our friend the 3 at the end. So hopefully you can recognize that 10 on 4 is the same as 5 on 2. So our square root disappears and we're left with 38 minus 50 on 4 plus 3. And that's because 25 on 2 is 50 on 4, right? So 38 minus 50 is 12. So we've got minus 12 on 4 plus 3. And minus 12 divided by 4 is 3. Plus 3 gives us 0. And there we go. Okay, so that's as masochistic as I'm going to get. You can check the answers for minus 5 minus root 13 on 2 if you want. It'd be a great surd workout for you. However, if you notice we've got the minus root 13 here, all that's going to really do is change this sign to positive and this sign to negative, which will end up being the same answer, right? But anyhow, as I said, try for yourself. And anyhow, I've made my point that the solutions are correct. Okay, let's move on to part B, where our quadratic equation is 2x squared minus 2x minus 1 equals 0. So therefore, we've got an a of 2, a b of minus 2, and a c of minus 1. So subbing those formulas into the equation, that means the value of x that satisfies this is minus 2, plus and minus the square root of minus 2 squared minus 4 times 2 times minus 1 all over 2 times 2. As I said, if you're super confident, you could skip that step. But for a lot of you, it's really important that I do use the brackets and make it super clear which number represents A, B, or C, okay? So we can now clean that up as minus 2 is 2, and 2 squared is 4, and we have a minus 4 times 2 times minus 1 is plus 8, and that's all on 4. And clearly we've got 2 plus or minus root 12 on 4. And as a little side note, you should know that root 12 is equal to 2 times root 3. So therefore, let's change that. And we can divide everything there by 2. So we've now got 1 plus or minus root 3 all over 2. We've just taken out common factors of each element there, okay? So this means that x is equal to 1 plus root 3 on 2, or x is equal to 1 minus root 3 on 2. And of course, you can check this if you want, but maybe it's going to be more fun to wait until we start graphing in the next block. Anyhow, at this point, I suggest you pause the video and work on questions 3 and 4 in the new book, or questions 5 and 6 in the old book. I know this equation looks complicated, but using it shouldn't be too hard. But also make sure you take some time to understand exactly what's happening. Alright, I'll see you in the summary. We've now finished the second block of this unit. So you should now be capable of factoring and solving any quadratic. But now this unit is going to change gear and we're going to start to graph the quadratics. And everything from the first 2 blocks of this unit are necessary for graphing. In this exercise, there are a few questions that really show you how useful the quadratic formula is. You can try questions 6 and 9 in the new book and 8 and 11 in the old book as some extra pre-learning. But anyhow, and of course, if you don't do it as pre-learning, it's something I definitely hope that you do in the class. Anyhow, for this lesson, a successful student will know the quadratic formula and when to apply it. Be able to use the quadratic formula to solve a quadratic equation. Know what the discriminant is and what it can be used for, and be able to use the discriminant to determine the number of solutions of a quadratic equation. Okay, so they're all the keys to success. Make sure you study hard, get them all down, and we'll see you in class or the next video. Bye.